In case a Kruskal-Wallis test turns out to be significant, it is of interest to the researcher between which groups differences in regard to the dependent variable can be observed. To achieve this, pairwise comparisons are being done. In my previous video for the general calculation of the Kruskal-Wallis test, I already requested all pairwise at the multiple comparisons option. They are presented a bit further down the output and are the main focus now. SPSS uses Dunn's tests for this, which will retain the ranking from all of your groups and also performs better than Mann-Whitney-Wilcoxon tests when you have tied ranks, which is of course more likely the larger your sample is. The table Pairwise Comparisons of Intervention shows all possible comparisons and the respective significance. The fancy diagram will do the same, by the way. To counter the alpha error inflation caused by multiple pairwise comparisons, p-values presented in the pairwise table are adjusted and presented in the last column. The method used here is Bonferroni, where your p-value will be multiplied with the number of pairwise comparisons being done. This is the most conservative approach and you can't go wrong with that. The more pairwise comparisons you have, the heavier this hits, and one can argue to use a different alpha error correction, which has to be done by hand though. Looking at the adjusted p-values, 2 are low enough. In my example, I can observe differences between the control group, none, and the meditation group, as well as between the control group and the mentoring group. The mentoring and meditation group have a p-value some might still consider for further investigation and/or interpretation. Please consult the paper, the ASA statement on p-values, and draw your own conclusions. Finally, you might have a significant Kruskal-Wallis test and no low enough p-values in post-hoc-testing when controlling for alpha error inflation. That is not a contradiction, and the internet is full of discussions about this phenomenon of significant tests and non-significant post-hoc tests. Just keep in mind that a p-value, to which it all boils down to, is a function of sample size, which decreases with an increase in sample size for any effect size that is different from 0. So, a non-significant test result in almost all cases tells you you're lacking statistical power as a result of too small of a sample. In my example, a couple more observations and therefore higher power would probably lead to a low enough p-value. Anyhow, please don't do post-hoc power analysis though to justify your non-findings, because the observed power is a one-to-one function of the p-value. After doing post-hoc tests, you should calculate the effect sizes for observed differences, which is shown in the following video.